When you're factoring, the first thing you need to look for is the greatest common factor, otherwise known as the GCF. What this means is it's the largest thing that goes into every single term in the problem. So for our first example, 3x minus 6y, we ask ourselves what number goes into both 3 and 6. And we want to look for the largest number. 3. 3 is the only number that goes into both 3 and 6. So 3 will be my greatest common factor. X and y have nothing in common, so I can't do anything with them. When I'm factoring, what I'm really doing is dividing out. But what I factor out has to stay in front of the problem. It doesn't just disappear. So when I do 3x divided by 3, I'm left with x. When I do negative 6y divided by 3, I'm left with negative 2y. That's my answer. I could check it by distributing, and I would get 3x minus 6y. Be careful that the answer that you circle is the one that I've circled here in yellow, not the original problem. Now when I look at my second example, 12x squared minus 9y, I look at them and I ask myself what goes into both. And again, it's just a 3. When I factor out a 3, I'm left with 4x squared minus 3y. That doesn't factor any further, so there's my final answer. Sometimes you'll also have a variable in there. For example, in my next problem, when I look at 6, 3, and 9, their greatest common factor is 3. But when I look at all three terms, at the variables, I notice that I have an x in each one of them, so I can also factor out an x. When I do 3x squared divided by 3x, 6 divided by 3 is 2. X squared divided by x, I'm left with 1x inside. When I do negative 3xy divided by 3x, the 3 and the x cancel, but I'm left with a negative y. Be careful that you don't forget the signs. 9xy squared divided by 3x will be 9 divided by 3 gives me 3. The x's will factor out all the way, but I will be left with a y squared. And that will be my answer for this one. With my last example here, I can take out a 5x, and I'm left with 3x minus 1. The minus 1 part is something you need to be careful of, because otherwise you'll lose that last term when you go to distribute and check it. So make sure that if you have two terms in your original problem, that you also have two terms inside the parentheses. Or you can always check by, at least in your head, distributing 5x times 3x, which is 15x squared, and 5x times negative 1, which is negative 5x. So that checks out. But the answer is the one that I have circled. All of the problems that you have in section A are like this. I'm going to give you two problems to try first on your own. Copy down these problems, hit pause, try them. When you're ready to check, hit play again. In the first example, 4x is my common denominator, and I divided that out of each term. My second example, 8 is the largest thing that goes into both 16 and 24. With the x's, I have an x squared and an x, so the most I can take out is 1x. But with the y's, I have y cubed and y squared, so the most I can take out is y squared. With the variables, you can always take out your lowest exponent as long as it's in each of the terms. So as I said before, all of your problems on your homework in section A are greatest common factor problems. So use these examples to guide you through how to do part A on your homework. Difference of squares is the next type of problem we're going to review. That means you have something squared minus something else squared. When you factor this, a squared minus b squared will factor into either a minus b times a plus b, or I could change the order and do a plus b times a minus b. What this means is I have something like x squared minus 9. I need to be able to take the square root of both pieces, both the x squared and the 9, and the piece about it being a difference means it has to be a subtraction problem. So I can take the square root of x squared, it's going to be x. That would be my a value. I can also take the square root of 9, it's 3. That will be my b value. One has to be positive, one has to be negative, and again, it doesn't matter the order that you write them in. If I have something like 25x squared minus 36y squared, I look at both parts and I ask myself, what's the square root of 25? Which is 5. What's the square root of x squared? That's x. What's the square root of 36? 6. What's the square root of y squared? Y. One has to be positive, one has to be negative. The order doesn't matter. If we have something like 36x squared minus 1, don't forget that minus 1, square root of 1 is 1. So we get 6x minus 1 times 6x plus 1. If in a problem you have maybe x squared plus 4, when I look at this, I think to myself, yeah, I know the square root of x squared, and I know the square root of 4, but this is not a difference of squares. So this is a prime problem. Prime means it cannot be factored. You will not say no solution, you will write prime. And it's because there's not a difference of squares. If the problem given, however, is negative 16 plus x squared, there is a negative sign in this problem. This can be rewritten as x squared minus 16, which is a difference of squares, which factors into x minus 4, x plus 4. So as long as there's one that's negative and one that's positive, it can be rewritten in the terms of a difference of squares. I'm going to give you two problems to copy down. Once they're there, hit pause. Don't hit play until you've solved them. Please try solving 49x squared minus 16 and factoring 1 minus 9y squared. Please hit pause now. So the square root of 49x squared is 7x, and the square root of 16 is 4, so it factors into 7x minus 4 times 7x plus 4. And for number 4, the square root of 1 is 1, the square root of 9y squared is 3y, so it factors into 1 minus 3y times 1 plus 3y. All of the problems in section B are examples like this. Now, these problems combine the two previous concepts, greatest common factor and difference of squares. Like I said earlier, the very first thing you should do with all problems is look for a greatest common factor. So with the one on the left, I can factor out a 4, leaving me with x squared minus 4. Now, when I look at the x squared minus 4, I do see that that's a difference of squares. I need to keep my greatest common factor and then factor the x minus 4 into x minus 2, x plus 2. The same thing will happen with the second problem. I again have a greatest common factor of 3y, and I'm left with 9x squared minus 4, which is also a difference of squares. So I keep my GCF of 3y, and then 9x squared minus 4 factors into 3x plus 2 times 3x minus 2. So look for your greatest common factor first, then see if you have a different squares that can be factored further. I'll give you two problems to try, and hit pause to solve. Please try these two problems now. Hit play when you're ready to watch them. Both examples had a GCF. Number 5, you could take out a 25, and you're left with x squared minus 4, which was a difference of squared and factored into x minus 2x plus 2. Don't forget to keep the 25 in your answer. Number 6 also had a greatest common factor of 2, leaving me with 9x squared minus 25y squared, which also factored as a difference of squares into 3x minus 5y and 3x plus 5y. Don't forget to keep the 2 as your GCF. All of the problems in section C are problems like this. The last type of problem we're going to review are trinomials. That means there are 3 terms. Neither one of these problems has a greatest common factor. So the first thing we're going to do is just start to try to factor this. My x squared will split up into x times x. The next thing I look at is my plus 2. If this second sign here is positive, that means that both of my signs in my factors will be the same, and they will both be whatever that sign in front of the middle term is. So these will both be plus. And then what I ask myself is, what multiplies to be 2 and adds to be 3? There's only two things that multiply to be 2, 1 times 2. And 1 plus 2 does equal 3. I can double check this by FOILing, and I will get x squared plus 3x plus 2. For my second example here, once again I'll split up x squared into x and x. My second sign is positive, which means both of my other signs will be the same, and they will both be minus this time. But I'll still ask myself what multiplies to be 6 and adds to be 5. Well, now I have other combinations that multiply to be 6. I have 1 and 6 and 2 and 3. But I'm adding them to get 5. 1 plus 6 is 7, which will not work, and 2 plus 3 is 5, which will work. The negative in front of the 5x comes from the negative in front of both the negative 2 and the negative 3. If I were to FOIL this, I would get x squared minus 5x plus 6. Please try factoring x squared minus 7x plus 12 and x squared plus 6x plus 8 now. When you're ready to see the answers, hit play again. Now x squared minus 7x plus 12, again, has the second sign as the positive, so both of the signs will be the one that's first, which is a minus. When I'm looking at the 12, I'm asking myself what multiplies to be 12 and adds to be 7. So while 1 times 12 does give me 12, that does not add to be 7. 2 times 6 also multiplies to be 12, but that does not add to be 7. So we're left with 3 times 4, which does multiply to be 12 and does add to be 7. And when I have x squared plus 6x plus 8, I know both of my signs will be positive because of the plus in front of the 6x. I ask myself what multiplies to be 8 and adds to be 6. 1 and 8 do not, but 2 and 4 do. So that's why I have plus 2 and plus 4. Now, when the second sign is negative, what that means is that when I factor this, my two signs in my parentheses will be different. One will be positive, one will be negative. And when I'm asking myself what factors are going to work, I will now say subtract in my head. So I'm going to look at what multiplies to be 4 and subtracts to be 3. So I have 1 and 4 and 2 and 2. 2 minus 2 does not give me 3. And 1 minus 4 does, if the 1 is positive and the 4 is negative. So I get x and negative 4x. Those will add up to be negative 3x, as long as the negative is in front of the 4 and the positive is in front of the 1. So I'll often check to make sure that those multiply out. Sometimes I won't fill my signs until later, even if I know they're going to be different. So again, I know they're going to be different. And this time, as I ask myself what multiplies to be negative 14 and subtracts to be 3, I only have 1 and 14, which does not subtract to be 3, 2 and 7, which does not subtract to be 3, and those are my only options. So I will say again that this problem is prime. Now when I look at this problem, again, I know my signs will be different. One will be positive, one will be negative. I'm going to fill those in later though. I look at what multiplies to be 24. I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. I'm asking myself what subtracts, though, to be 5. The only pair that has a difference of 5 is 3 and 8. So I'll fill in 3 and 8. But I need to be aware that it has to be positive when I'm done. So that's only going to work if I have negative 3 and positive 8 as my signs. Please try both of these problems after you hit pause. When you're done, hit play so you can check your answers. The first one factors into x minus 8 times x plus 1 because the signs need to be different, and negative 8 plus 1 will give me negative 7. And the second one, they also need to be different, so it's plus 8 and minus 4, and positive 8 minus 4 does give us positive 4. All the problems in section D on your homework are trinomial review. We will be continuing to practice this, but if you don't remember this, you definitely want to make sure you see me or the math lab because we're not going to be spending a lot of time on this in class.